Welcome to the fourth in our series of 5 lectures on the topic of climate change. We're going to be moving from those of you that were with us a few days ago. We were on the oceans and on the ice caps of the planet. Very interestingly, tonight we're going to be moving back onto land and are going to be looking at the impact of climate change on interstate relations, a strategic view of climate change, quite different from what we've been doing thus far. We have one more lecture scheduled exactly 2 weeks from now on the 2nd of December, and that will be focused on mitigation and adaptation to the consequences of climate change. And we've asked Dr. Nathan Holtman of the University of Maryland to be with us on that occasion, and I hope that you'll join us for that as well. I do want to take just 1 second to do something that's very important, which is to thank not only you for coming and joining with us on this, I think, rather important series of lectures in an effort to build up our understanding of COP18, which is about to descend in full force upon our city beginning on the 26th of November. But I also want to thank all of the people. I will not name them all because it's quite a list of people, my colleagues on the faculty and the administration and the staff and students who've been helping us all along make this series of lectures a great success, I think. And I'll thank them again in various ways, but I certainly want to express my gratitude to all of them tonight. Anyway, I'd like to call upon Eileen Francis to introduce our speaker for this evening. Eileen.
Dr. Brahma Chellaney is a professor of strategic studies at the Center for Policy Research in New Delhi. He has served as a member of the Policy Advisory Group headed by the Foreign Minister of India. Professor Chellaney has been an advisor to India's National Security Council and served as a convener of the External Security Group of the National Security Advisory Board. A specialist on international security and arms control issues, Professor Chellaney has held appointments at Harvard University, the Brookings Institution, the Johns Hopkins University School of Advanced International Studies, and the Australian National University. Dr. Chellaney is the author of 6 books, including Asian Juggernaut, The Rise of China, India, and Japan, and On the Frontline of Climate Change, International Security Implications, co-authored with Hila Najibullah. His latest book is Water, Asia's New Battleground, published in 2011 by Georgetown University Press. He has published numerous research papers in, among other leading journals, International Security, Orbis, Survival, Washington Quarterly, Security Studies, and Terrorism. Professor Chellaney is also a newspaper columnist and television commentator. He regularly contributes opinion articles to the International Herald Tribune, the Wall Street Journal, Japan Times, Asian Age, Hindustan Times, and the Times of India. In 1985, he won a citation for excellence from the Overseas Press Club in New York City. Professor Chellaney.
We're discussing the most critical natural resource, water. Water is essential to produce virtually all the goods that we find in the marketplace. It's essential also to refine oil and gas, to produce electricity, and to extract, to mine coal and uranium. There are substitutes for oil and gas, but there's no substitute for water. Today, about half the global population lives in conditions of water stress. And according to the United Nations, this figure will grow to 2/3 of the global population by 2020, which is only 8 years from now. if you look at Qatar, it is so rich in hydrocarbons, but it's so poor in freshwater resources. In fact, as this particular chart will show, it's the fourth poorest country in the world in terms of freshwater resources. There's a very close relationship between water and climate. Water moves on the Earth's surface by gravity, and that movement by gravity, along with the processes of evaporation and condensation, propel the Earth's biogeochemical processes and cycles and helps regulate the climate. Human alterations of the hydrological cycle affect climate stability and affect climate in general, while changes in climate, that is climate variability, has a very adverse impact on water resources. To give you just one example of one natural system, coastal wetlands. Coastal wetlands are the bridge between freshwater ecosystems and saltwater ecosystems. Just the way the rainforests are the Earth's lungs they filter the air, similarly, coastal wetlands are the Earth's kidneys because they act as a water filter. But many coastal wetlands in the world have been degraded, and their vegetation has disappeared. For example, half of all tropical mangrove forests in the world have been destroyed. The vegetation of coastal wetlands safeguards against flooding during storms and hurricanes, and also safeguards against saltwater incursion and coastal erosion. Now, this is just one example of how human beings are altering the natural systems. Qatar, as you all know, is going to host a United Nations Climate Change Conference shortly. But the deliberations aren't going to be easy. The international community recognizes and accepts that safeguarding the global commons, including the hydrosphere and the atmosphere, is the common responsibility of all. Yet, developing common norms and developing an action plan are proving difficult. Human alterations of natural systems have become so profound that the Earth has entered what some scholars are calling a new age of geological time, the Anthropocene, in which human civilization, not nature, is the driving force in the transformation of ecosystems. In fact, human-induced alterations of freshwater ecosystems are even more profound than the transformations of the terrestrial ecosystems. And this, in turn, is having an impact on climate. Climate stability is becoming a casualty. For example, the introduction of irrigation in arid and semi-arid areas has created atmospheric humidity affecting regional climate. From a natural resources standpoint, human civilization is approaching a tipping point. Nowhere are the pressures on natural resources greater than in Asia, which is the world's largest, most densely populated continent. It is also the fastest developing continent. water in particular has emerged as an issue that will determine if Asia is headed towards greater cooperation or greater competition. People think of Africa as being the driest continent. Actually, it's Asia, which is the driest continent in the world, as this chart will show you. Asia has only 1/10 the water of South America or Australia and New Zealand. It has less than 1/4 of the water of North America, almost 1/3 of Europe, and 25% less than Africa. Yet, the world's fastest growing demand for water, for food and industrial production, and for municipal supply is in Asia, which, as you know, has become the locomotive of the global economy. Asia's dynamic economies are all in or near conditions of water stress. The IPCC, which is the Intergovernmental Panel on Climate Change, this is the gold standard on climate science. The IPCC has been doing research and publishing reports on a periodic basis since the 1990s. In its last series of reports, it warned of the increased likelihood of water conflicts in Asia. There are two things about Asia that stand out. One is about the high dependency ratio on cross-border water inflows. And because much of Asia's water is shared water, water disputes between countries and within countries are quite common. The other aspect about Asia is the high reliance on irrigation. If you look at this particular map, you will see this is just Southeast Asia and South Asia. But this is true of rest of Asia too. You can see the high dependence on cross-border river flows. And these are all Himalayan rivers, which are flowing to different countries. Only one country is not dependent on cross-border water inflows, and that's China. China is in the lucky position of not having to depend on others. It has one of the lowest dependency ratio in the world. Less than 1% of its water comes from across its borders. The reason for that is that the way Israel changed the sub-regional water map in 1967 through a 6-day war by grabbing the Golan Heights, which controls the headwaters of the Jordan River, and Israel also in that war occupied the West Bank, which controls the aquifers. China, after the formation of the People's Republic of China in 1949, asserted control over Xinjiang and annexed the Tibetan Plateau, which is the world's largest repository of accessible fresh water. So that changed the water map of Asia. Today, China is a supplier of water to the largest number of countries in the world. No country in the world actually matches this kind of riparian status and role of China. But other countries in Asia are highly dependent on water inflows. Another issue that I mentioned was about irrigation. Irrigation has proven to be both a boon and a curse in Asia. Asia used to be a continent of recurrent food shortages until the 1960s. Then it embarked on a very ambitious program of expanding its irrigated area. The rain in Asia comes during the monsoons, and it's concentrated in a 3-month or a 4-month period. The rest of the year is relatively dry. You cannot grow crops in the other periods without artificial irrigation. And because irrigation in Asia was restricted, Asia was always food short until the 1960s. But from the 1960s, it embarked on this major expansion of irrigation. And today, 70% of the world's total irrigated land is in just one continent, Asia. Asia is the world's irrigation hub. And because of this irrigation expansion, Asia in just 20 years went from being food short to being food surplus, becoming an important exporter of food in the world. Now, this is a great food success story that has transformed Asia. It laid the foundation for Asia's economic rise. But this has come at a major price. That's why I said irrigation is also a curse. 81% of Asia's annual water supply is channeled for irrigation, for agriculture. Now, looking ahead, this kind of supply being monopolized by one sector is just not sustainable. After all, Asia is becoming the global manufacturing hub, and the cities of Asia are growing. Asia has so many mega cities now. So municipal demand is growing, industrial demand is growing, and the only savings have to come from agriculture, which means Asia has to produce more food with less water and even less land. Why? Because cities and industries are encroaching on arable land. So this is a big challenge for Asia, looking ahead, to grow more food with less water, less land, and even less energy, which means using less nitrogen fertilizers, which are a major problem of water pollution in Asia as well as elsewhere. The great Himalayan watershed has the greatest water resources in the world. The North and South poles together have far more freshwater reserves than the great Himalayan watershed. But the water in the two poles is all locked up in ice. The great Himalayan watershed not only has colossal water resources, it's also on the front lines of global warming. What are the factors that have endowed this region with such colossal water resources? One factor in particular. If you look at mountains, tall mountains in the world, all the mountains in the world of 7,000 meter and more height are all in this area. In fact, the tallest peaks in the Great Himalayas are higher than 8,000 meters. And because of their height, these Himalayan mountains trap the monsoonal currents in their midst. They prevent these monsoonal currents from moving further upwards. That's how heavy precipitation occurs in the Great Himalayan region. Precipitation, by that I mean both snow and rain. And that's one factor that has endowed this region with exceptional water resources. This entire Himalayan region stretches 3,500 kilometers from east to west, from the northern tip of Burma, Myanmar, to the Hindu Kush mountain range in Afghanistan. And if you include the adjacent mountain ranges to the west of the Himalayas, like the Pamirs, the Kulnul, the Karakoram, the Hindu Kush, and the Tian Shan, you get what is called the extended Himalayan range, or the Great Himalayan Watershed. The European Alps are the water tower of Europe, but in comparison, the Great Himalayan Watershed is a water tower of unmatched size. Concerns about the impact of climate change on the Great Himalayan Watershed center on two issues. One is the impact on its glaciers, and the second is the warming trend that is being seen on the Tibetan Plateau, which plays a unique role in Asia's hydrology, ecology, and climate. Let me explain both these issues. First, the impact on glaciers. There are thousands of glaciers in the Himalayas, and various studies have shown that a number of them are thawing at an accelerated rate. Glacial shrinkage that we are witnessing, not only in the Great Himalayan region, but also in the Rockies and other parts of the Northern Hemisphere, such shrinkage would mean that there'll be increased meltwater flows for the next 3-4 decades until the situation quickly changes from plenty to paucity of water resources. There are, in this region, in the actual Himalayas itself, about 18,000 high-altitude glaciers, 18,000. And they cover about 17% of the entire Himalayan region. The Himalayan portion in Tibet has 3 times more glacier area than the Himalayan portion in India. Another important thing about glaciers in general is that they are massive storehouses of water. If all the glaciers of the world melted, the seas would rise by 80 meters, inundating most coastal areas. This education city would be underwater. So the thawing of glaciers that we are seeing from a long-term standpoint, and this thawing is happening because of global warming. So from a long-term perspective, this has important implications for water supply. And this suggests that, that the impact on water resources, especially on river flows, will be serious, especially on rivers that are highly dependent on melting ice and snow. Some rivers are heavily dependent on rainwater. Some rivers depend heavily on glacial and snow melt. And this particular chart will show you which rivers in the Great Himalayan region are highly dependent on melting ice and snow. One, as you can see, one is the Indus. The Indus flows from India to Pakistan, and these are all different rivers of the Indus system, and it flows through a disputed area, which is Kashmir. This is another endangered river, Brahmaputra. It flows from west to east for about 2,200 kilometers, largely through glaciated area, collecting the glacial meltwaters. And then it makes a very interesting and strange U-turn. You can see that U-turn, and it enters India. And then it makes that U-turn. It creates the world's greatest canyon. It's the deepest canyon in the world and holds enormous water reserves. This is another endangered river because it depends very heavily on melting ice and snow. This is a river in southern Xinjiang. And then there are 2 rivers of Central Asia, the Sir Darya and the Amu Darya. These are the lifelines of Central Asia. The Fergana Valley of Central Asia is where the population is concentrated because this is a very fertile, agriculturally rich area. the point that I'm trying to make is that because of global warming, earlier spring and summer runoff would actually lead to reduced dry season flows. And such shifts in runoff patterns will negatively impact agriculture. It will also negatively impact hydropower generation and drive many, many farmers into cities. Now, turning to the impact on the Tibetan Plateau. The Tibetan Plateau plays a unique triple role. First, it is Asia's largest freshwater repository. Second, it is Asia's main water supplier. As you can see from this map, almost all the important rivers of Asia originate from one region, the Tibetan Plateau. Only the Ganges, among all the important rivers of Asia, Ganges is the only river that does not originate from the Tibetan Plateau. And the third role is that the Tibetan Plateau is the principal rainmaker. How is it the principal rainmaker? In the summer, it acts as a high elevation heat pump, drawing in monsoonal currents from the different oceans, from the East and South China Seas, from Indian Ocean, Bay of Bengal, and the Arabian Sea. That's how Asia's famous monsoons occur. The Tibetan Plateau is called the roof of the world, not just because it's the world's highest plateau. In fact, the elevation on the Tibetan Plateau is more than 4,000 meters. It's called the roof of the world because it rises to the middle of the troposphere. The troposphere is the lowest and most dense layer of the atmosphere. Because of its height, the Tibetan Plateau influences climatic patterns and atmospheric general circulation, not just in Asia, across the northern hemisphere. So the weather in Qatar or the climate in Europe is influenced by what happens on the Tibetan Plateau. If there is environmental degradation on the Tibetan Plateau, it'll affect the atmospheric general circulation. Atmospheric general circulation is the movement of warm air from the equator to the higher latitudes, creating in the process different climatic zones. So if the atmospheric general circulation is weakened, altered, or transformed in any manner, this will mean climatic instability even in Europe or the Middle East. And the Tibetan Plateau is rich not only in water, it's also rich in many other natural resources, especially mineral ores. It has become China's new mining center. But coming to the point, because of its special features and role, the Tibetan Plateau is both a driver and amplifier of global warming. And two major developments are happening on the Tibetan Plateau. First, various studies have shown that the Tibetan Plateau is warming faster than the global average, in part because of its very high elevation. So it actually absorbs more radiation from the sun, and therefore it actually heats up faster than the rest of the world. The second development that we are seeing is the shrinkage of its permafrost. What is permafrost? Permafrost is permanently frozen ground. It's called permafrost. It's just ice on the ground, which stays there indefinitely. But that recession, the shrinkage that we are seeing in the Tibetan Plateau is entirely because of global warming. And this has again important implications for water supply, because permafrost is the wellspring of lakes and wetlands. And many lakes of the Tibetan Plateau are important sources of supply to rivers. Now, this brings me to a different point, which is the distinction between environmental change and climate change. Often the distinction between environmental change and climate change is blurred in popular discourse. And any extreme weather event is linked with global warming. Any single episode of extreme weather cannot conclusively be attributed to climate change because climate variation has to be studied not over months or years, but over decades and probably over centuries. But the important point is that human-induced environmental change, such as land and water degradation, waste mismanagement, and destruction of natural habitats, does contribute to climate change over time. In other words, human-induced environmental change is a stepping stone to climate change. This can be seen from the large-scale destruction of forests in the Great Himalayan Watershed. These are two pictures taken 42 years apart by satellite. The first picture was taken in 1950, and the second picture is from 1992. And these different colors that you see, dark blue, light blue, are forests of a different kind. And you can see how, in a generation and a half, this great Himalayan watershed has been denuded of its rich forests to a large extent, especially on the Tibetan Plateau's southern belt. Now, this inevitably will impact climate change. Why? Because natural forest cover serves to regulate water runoff, it regulates river flows, it also serves as a carbon sink. So the elimination of forest cover on the scale that we see will affect the runoff regime and will lead to increase in regional temperature. Now let me quickly turn to another water danger. This is a danger from the rising oceans because of climate change. This is an existential threat to low-lying nations, a specter that can also create permanently displaced climate migrants who can bring freshwater resources under strain in the new habitats to which they relocate. In Asia, the economic boom areas are concentrated along the coasts. About 37% of the world's population today lives within 100 kilometers of a coastline, but a much bigger percentage of Asia's population lives by the coastline. Asia's megacities are by the coast. Much of Asia's GDP growth is concentrated along the coast. And according to the Asian Development Bank study released a couple of years ago, this region, Southeast Asia in particular, is very vulnerable to the effects of the rise of ocean levels. Why? This region has 3.3% of the world's global landmass, but it has more than 11% of the world's coastline. So it's very vulnerable to the effects of the rise of ocean levels, and that's the reason why the countries of Southeast Asia have created a special plan, a food buffer to protect, in the case of natural disasters caused in the form of storms, hurricanes, etc. But as Fukushima showed Asia as a whole is highly exposed to water-related disasters. This is a reminder that water is not only a life preserver, it can also be a life destroyer if it takes the form of flash floods, hurricanes, and tsunamis, or becomes laced with deadly bacteria. Water pollution is as much a problem in Asia as water scarcity. In fact, if you look at China, officially, the Chinese government says that 30% of China's water is so polluted, it's not even usable on farms. So if you extract the 30% from its total water resources figure, you see a very different picture of what's usable in China. Another issue is saltwater incursion into continental Asia, which is eating up land. The destruction of vegetation along the coast and also the overexploitation of coastal aquifers is inviting saltwater to intrude. And we're seeing that intrusion becoming a threat not only to low-lying island nations, but also to a large country like Bangladesh. Bangladesh is the 7th most populous country in the world. It's a country that has been formed by the great deltas of two big Himalayan rivers, the Brahmaputra and the Ganges. Of course, there are many other rivers there. For example, Meghna is a major river, and all these rivers blend into one delta. So 1/3 of Bangladesh is situated less than 6 meters above sea level, less than 6 meters above sea level. And saltwater incursion is eating up Bangladeshi territory. According to the IPCC that I mentioned earlier, Bangladesh is set to lose 17% of its landmass and 30% of its production of food by 2050. Another factor that is contributing to environmental change in Asia is the overdamming of rivers. The Aral Sea disaster, the Aral Sea has shrunk to less than half its size. It's largely because of the overdrawing of waters. The overdamming plus the overdrawing of waters of its two sources, the Amu Darya and the Sid Darya rivers, which are, as I mentioned earlier, the lifeblood for Central Asia. Now Lake Balkhash in Kazakhstan risks becoming another Aral Sea because China is building various projects upstream on Ili River, which is a source of Lake Balkhash. There are about 50,000 large dams in the world, 50,000 large dams in the world. And the vast majority of large dams in the world are in one continent, Asia. In fact, one country alone has more dams than the rest of the world combined. And that country, your guess, I'm sure, you can guess which that country is, China. And these are not the existing dams. These are the dams approved for construction now. This is a map released by HydroChina and shows dams that have been approved by the State Council, which is the cabinet of China, and was released in 2010, and some of the dams that they show are already under construction. But you don't see this on the map, but you can see it on the internet if you open this map, that the largest dams on this map are on the borderlands of China on international rivers. According to the IPCC again, the overdamming of rivers in Asia, and China is not the only culprit, other countries are also overdamming the rivers. The overdamming of rivers is causing a retreat of Asia's 11 densely populated megadeltas. These megadeltas have been formed and they are fed by rivers that originate on the Tibetan Plateau. And because of this overdamming of rivers, the silt flow, the sediment flow from the mountains, which is a nutrient-rich silt, nutrient-rich material, that is getting trapped by the dams. And because of that entrapment, the deltas are beginning to retreat. And these deltas, as you probably know, are home to megacities like Tianjin, Shanghai, Guangzhou, Bangkok, Dhaka, Calcutta, and Karachi. So these are different aspects of how environmental change is reinforcing climate change and exacerbating Asia's challenges. So to conclude, and I just have some thoughts to share with you. Climate change as a subject has been highly politicized, with tensions running high between competing national interests over how and at what cost to build a low-carbon future. This is a reminder that climate change is not just a matter of science, it's also a matter of geopolitics. Without improved geopolitics, we will see no concerted international action to combat climate change. That's the reason why one should not raise too high a hope about the Qatar Climate Change Conference. Second, we must recognize that there are important gaps in our scientific understanding of the phenomenon of climate change. Climate change is still a science in progress. It is a young science. We do not know everything. More scientific research is needed to understand certain phenomena, to plug the gaps in our knowledge. For example, what caused the little ice age from the 15th century to the 19th century? The little ice age ended with the advent of the Industrial Revolution. The Industrial Revolution began emitting a lot of carbon and began raising the global temperature. But climate change is just not a phenomenon from the 19th century. If you see the journal Science, last week's issue, it has a study which contends that the ancient Mayan civilization of Central Asia, that civilization collapsed, according to this study, due to climate change. So climate change is a phenomenon that has haunted human civilization for long. Now, thanks to all this awareness on climate change, thanks to the IPCC studies, we now know more about the human factors that contribute to climate change. We now know more about the human factors than about the Earth's natural climatic variations. Yet, whatever we know, whatever is available scientifically, tells us that the impact of climate change on long-term water resources and water supply will be serious in the most conservative scenarios. Two likely effects are beyond dispute in the scientific literature. You have a lot of climate change skeptics and many climate change enthusiasts. So in this tug of war, facts get squeezed. But there are two likely effects that are beyond dispute scientifically. One, that water stress will intensify and spread. And two, that the alterations, the changes in precipitation and runoff patterns will have important implications for food production in some areas, especially Himalayan Asia. So dealing with these challenges, with these shifts, will have to be part and parcel of adaptation to climate change. This particular map is a projection of water scarcity in the next decade. The yellow regions signify acute water stress, The dark blue areas signify high water stress. Now, this map really shows what we know today. This reflects today's pattern, that water stress or acute water stress or high water stress are concentrated in 3 areas: Asia, Middle East, and North Africa. Then you have some other areas, for example, the American Southwest, we all know today, is water distressed. There are some areas in Latin America on the western coast which are water stressed. There's a little area in southeast of England that you can see that's still water stressed. So what this particular projection shows is that the present patterns will continue at least until the next decade. Now, this brings me to a different subject. What the US intelligence released a public report a few months ago, and they had this warning in that report. And they, in fact, warned about water conflicts in Asia, warned about how situation in some basins in Asia was getting tense. Now, water war as a concept may not mesh with the conventional construct of warfare, especially to those who think of warfare in terms of tanks, attack submarines, fighter jets, etc. Water wars don't have to be fought in that style, because armies don't necessarily have to march to seize or defend water resources. Water wars can be waged and won by non-military means, including by re-engineering transboundary water flows. If you can alter the flows to a neighboring country, and you do it in a way that you alter the water flows to the detriment of your downstream neighbor, in effect, you have re-engineered water flows and caused damage to the other party. Water wars in a diplomatic, political, or economic sense are already being waged between riparian neighbors in several subregions, thereby fueling a cycle of bitter recrimination and impeding regional cooperation or regional integration. In fact, the resources of common rivers and aquifers have become the target of rival appropriation plans, because there's very little incentive for countries to leave river flows or aquifer flows for neighboring countries unless there are water sharing agreements in place. Now, the question is, how do we mitigate the risks? There are 2 sets of risks. One are the security risks of water wars, and the other are the economic risks from water scarcity and climate change. The security risks can be managed if Asian countries were to invest in institutionalized cooperation on shared water resources. There are 57 shared river basins in Asia, 57 in continental Asia. We don't know how many shared groundwater basins there are, because no scientific study has been done of groundwater basins in Asia. But river basins we can see with human eye. So we know how many river basins there are in Asia. There are 57. Only 4 of those 57 basins are covered by a water treaty that involves water sharing or institutionalized cooperation. In other words, 53 of the river basins in Asia have no agreement, no arrangement on cooperation. This is not a recipe for harmonized relationships, especially as we get into an era of increased water stress. So the way to manage the risks are for countries to invest in water institutions. Only water institutions can stem the risks of disputes not flaring into conflicts. How do we manage the economic risks of environmental and climate change? Here, there are three areas which are important, and I'll be telegraphic because I think I'm running out of time. The first area is improving Asia's water efficiency and productivity levels. And here, the big savings will have to come in agriculture, because agriculture being the big user of water, the savings will have to be garnered in that sector. And this requires no new technology. It requires using existing technology. That is, shifting from old-style gravity flow irrigation, where you allow the water to flow in canals onto the fields and flood the fields, shifting from that to macro-irrigation systems, known also as drip irrigation. That will mean 50 to 70% saving in water. You can't grow rice, by the way, through macro-irrigation, because you need to flood the fields to grow rice. But only 30% of Asia's total food production involves rice. The other 70% of food production in Asia can benefit from adoption of macro-irrigation systems. Less than 2% of the farmers in Asia today use macro-irrigation systems. The second area where we can mitigate the economic risks is by tapping unconventional, that is, non-traditional sources of supply. See what's happening in the energy sector. By tapping non-conventional sources of supply, like shale gas and shale oil, the energy sector has been transformed. The center of gravity in the hydrocarbon sector is now slowly shifting from the Middle East to the Americas, thanks to this shale gas and shale oil revolution. Similarly, in the water sector, we need to find unconventional sources of supply. Now, what are the unconventional sources of supply? One is wastewater. The water that we waste at home, in factories, elsewhere. For example, industries, energy plants, waste all that water. If we can reuse that water, it'll augment the water supply enormously. Another is what Qatar is doing, which is to use seawater, desalinating seawater. The problem with both wastewater treatment and desalination today is that they're both energy intensive. They're energy intensive and they leave behind toxic residues whose safe disposal poses a serious challenge. But think of a scenario in the coming years of solar-powered desalination or solar-powered wastewater treatment. That would be the silver bullet answer to the world's water problems. A third unconventional source of supply would be brackish water. What is brackish water? Brackish water is found either in coastal areas or in the hinterland, underground. It's salty, but not so salty as seawater. So it requires much milder treatment than ocean water. Brackish water treatment costs only 1/3 the cost of treating ocean water. And there's a lot of brackish water in several parts of the world. In the United States, there's huge quantity of brackish water, inland as well as in coastal areas. So also in Asia. So using brackish water for different uses will be very useful. And also, when you tap unconventional sources of supply, you don't have to treat water to 100% purity. For example, if you were to use brackish water or wastewater for energy plants or for farming, 50 to 70% purity treatment would be sufficient. So you can reduce the costs depending on what your end use is. And the third area where we can actually find ways to mitigate the risks is through storage and supply. What do I mean by that? First, a lot of water gets lost in distribution. Distribution efficiency improvements have to be a priority. But the more important thing is that we get a lot of rain on this planet. The Earth's water-making capacity, water is a renewable source, and the Earth has a fixed capacity to renew water. And that quantity it can renew is 47,000 cubic kilometers per year. Since the first human being appeared on the Earth's capacity to renew water has remained the same. But 3 times more rainwater comes every year, 3 times more than the Earth's renewable capacity. Now, most of the rainwater drains into the oceans. It either falls directly on the oceans or it's carried to the oceans from land. Now, a lot of the rainwater that falls is valuable, has very important critical roles in ecology. We can only take some rainwater. Hypothetically, if we were to store 5% of rainwater, 5% only, imagine what a tremendous difference it would make to regional water availability, 5% only. And rainwater harvesting is an ancient technique developed in Asia, by the way. So what Asian economies need to do is to go back to their roots, discover the rainwater harvesting techniques. Already a number of places like Singapore, in the Indian cities of Chennai and Bangalore, you can't build a new building or a new apartment complex without a rainwater harvesting system in place. But this is not a general practice in other areas, and such practices need to be encouraged. So to now finally conclude, in addition to what I've mentioned, Asia also needs to invest in ecological restoration programs that seek to assist in the recovery of damaged or degraded ecosystems. The worst choice for Asian nations would be to whip up water nationalism, which has become a danger in some countries already, where water-related nationalism is manifest, or to treat the sharing of waters as a zero-sum game, or to use the tools of geoengineering to modify local or national climate. Weather modification technologies open a new human interventionist frontier with unpredictable and long-term consequences. In 2009, China, for example, did 2 weather modification experiments. One, they cleared the skies over Beijing right in time for the National Day Parade. And the second experiment, again in 2009, they wanted to create snow in Beijing. So they seeded the cloud seeding. But they created so much snow by mistake that they had to close 12 highways around Beijing. Now, weather modification technologies are not that simple, because you see, when you seed clouds, you suck in moisture from elsewhere. As I said, Earth's water recycling capacity is the same, and that means water and moisture. Everything, there's a link. So when you suck in moisture, you're denying another region, precipitation. And therefore, it's not that simple, that you just can't inject clouds and get more rain or snow and not expect adverse consequences for a neighboring region. But the more ominous thing about geoengineering technology, which is being developed, which is being experimented in some nations, is that it potentially creates a tool more dangerous than even nuclear weapons. Let me stop at that note. Thank you.
Thank you very, very much, Dr. Chellaney, for an extremely stimulating and informative lecture about the water problem of Asia. I'd like to open it up now for your questions. If I might seize the opportunity to ask the first one. You've made it very clear that China, with some 14 neighbors, but with almost all of the rivers flowing out of China rather than into it, is in a unique position of water autonomy, if you like. So what China does, what policies it adopts in regard to these transboundary rivers is supremely important. Would you share with us some of your thoughts about the likelihood, the probability that China might be moving in the direction of a cooperative attitude that might help to relieve the water scarcity problems in neighboring countries?
Well, thus far, China has been willing to share statistics, but not water. It's willing to share statistics on river flows. It wants to sell statistics, that is hydrological data, to neighboring countries, and it has agreements, contracts with several neighboring countries to sell hydrological data, but it has not entered into a single water sharing agreement with any neighboring country. And out of the 14 countries with which it has land borders, 13 of them are its riparian neighbors. In other words, it has a river-related relationship with that country. And with those 13 countries, with all those 13 countries, it has some water dispute or the other. Some disputes are more serious, some disputes are smaller in nature, but it has water disputes now with almost all its neighbors. So if Chinese decision makers were thinking mid to long term, they would have to factor in how their unilateralist approach on water resources, building of dams to appropriate cross-border water flows, how that is impacting their image on China's long-term interests. It seems to me that they are not bothered about the image as such. They're more bothered about appropriating what they believe, rightly or wrongly, as their sovereign right to tap into rivers that originate from the territory. In fact, they are open proponents of a doctrine called the doctrine of prior appropriation. There's no international water law, which actually aids China's current dam building program. But there is customary international water law. And in customary international water law, there is a doctrine called the doctrine of prior appropriation. And it's based on the dictum, first in time, first in right, which means that if you're the first to appropriate river waters, you will have the first priority over subsequent users. This doctrine has actually been upheld. It has been upheld by the US Supreme Court. It's known as the Colorado versus Wyoming doctrine in the US Supreme Court legal case history. And in 1997, when the United Nations passed a new convention, it's still not been ratified. That's why I said there's no international water law as yet. But in 1997, a convention on shared waters was passed by the United Nations. China opposed it, and in fact said on the record that it opposes this convention because it undermines the doctrine of prior appropriation. In other words, China asserts absolute territorial sovereignty over rivers that flow from its territory.
Hi, Dr. Chellaney. Thank you very much for such a fascinating lecture, and thank you for highlighting some of the mitigations that we could use for the risks that could come up in the future. I wanted to ask about some of your mitigations, specifically on the economic side. You've mentioned unconventional sources of supply, looking at water treatment. You've mentioned rainwater harvesting and macro irrigation, and all of these are very high energy intensive processes. Do you think in the short term there could be a compromise, or there could be a trade-off potentially, or some sort of a battle basically between carbon emissions and improving our mitigation for water supply? Do you think that there's some sort of trade-off between the two of these?
Well, it could conceivably, though it's not being developed in that sense. Micro-irrigation, wastewater treatment, desalination are very energy intensive. But micro-irrigation is not at all energy intensive because it uses very low wattage to move water through these pipes which have holes in them, and these pipes are laid on the ground, as you see in Qatar in many places. So the water is actually zoomed to the plant zones rather than being spread across the field. In fact, in the case of macro-irrigation systems, many of the manufacturers are now trying to sell macro-irrigation systems along with a solar system, because in Asia, like for example in India, power outages are very common, and farmers don't want to be at the mercy of the utility when they will resume the electricity supply. So if you buy a macro-irrigation system today, you can actually buy at the same time a solar powered system which will ensure 24-hour supply or give you the facility to water the plants, the fields, whenever you want. So there are these technologies which are, as I said, there's some low-hanging fruit to be plucked, which is not being plucked for some reason, even though in Asia, some governments are offering very heavy subsidies. In India, many state governments are offering 100% write-off to farmers if they were to adopt micro-irrigation systems. Some other state governments in India are offering 50% write-off. The problem is the mindset. These farmers have prospered in one generation or two generations using the old-style methods, which is to let the flood the fields, right? They are not paying for water because water is heavily subsidized. It's not free like in Qatar. The farmers in Qatar get it free, but farmers in Asia, like in China and India, have to pay less than the market price. But it's not the market price, and farmers in most of Asia have absolutely no regulation, that can regulate their pumping of groundwater. They just pump groundwater. In fact, electricity to farmers in large parts of Asia is subsidized. So they have an incentive to overexploit aquifer systems. So it's a vicious circle, where state policies are encouraging environmental degradation. And therefore, I can understand farmers being a very, they're pampered lot in all countries, as we all know. But in Asian societies, farmers are also numerically preponderant. In United States and Europe, 3 to 4% of the population grows food, and grows so much food that they even export. But more than 50% of Asians are employed in agriculture. So when you pursue policies that impact on agriculture, it has a huge impact politically, socially, etc. And therefore, governments are very afraid of touching farmers. And what surprises me is that I can understand the hesitation to impose any policy, but creating greater public awareness, social awareness on the benefits of macro-irrigation. Because yes, the upfront costs are heavy, but which governments are ready to subsidize. But the long-term benefits are enormous, because when you use macro-irrigation systems, you not only save on water, you save on fertilizer use, because the same system is used for applying fertilizers. It's called fertigation. So you apply fertilizers to the plant zones rather than spread chemical fertilizers across the field. So you use less chemical fertilizers, and your acreage improves. So you have benefits starting in a few years after you have adopted macro-irrigation systems. And therefore, what it requires, of course, in the case of desalination and wastewater treatment, we need to have improvements in technology to make it more cost-effective, more environmentally friendly. But in the case of macro-irrigation systems, these are already mature technologies, ready to be plucked.
Lubna, your question, please.
Dr. Chellaney, you talked about the large number of planned dams for the waters in China. What is the nature of these dams? Are they consumptive, non-consumptive in nature? And then,
Are they what, sorry?
Are they consumptive as in?
Consumptive.
And then, or non-consumptive? And then, what is the adverse effect? To what extent would they adversely affect India, Pakistan, Bangladesh, and the lower regions?
There are two types of dams. One are large storage dams. They have a reservoir in which they store water, and that reservoir then is used for various purposes. It can be used for water supply to cities and to farms, can be used for hydropower generation, can be used for energy production and for mining, etc. So storage dams usually are multi-purpose dams, and they have a consumptive use. What they store, portion of that is consumed. Second type of dam is known as the run of the river. The run of the river dam uses the river's natural drop in elevation to generate electricity without the need for storage. So these are single-purpose dams. Their only job is energy production. And these are non-consumptive dams. Because they really don't store water, the inflow and the outflow are the same. These dams, if they are built appropriately, can be environmentally considerate. I wouldn't say environmentally friendly, but they will not destroy or damage the environment. Everything has an impact on the environment, a little bit, but they will not be really injurious to the environment if they're designed properly. But the large storage dams have an impact on the ecology. And what's happened because of human development and technological development, that the size of dams in the world has been increasing rapidly. For example, the Hoover Dam, built during the Great Depression in America in the 1930s, was for many, many years thereafter regarded as a new wonder of the world, right? But now China has built so many dams which are so much bigger than the Hoover Dam, that the Hoover Dam pales in comparison to these large dams in China. Not just the Three Gorges Dam, but the new dams that China has built on the Mekong River, for example. The Nuazadu, which they completed, the first phase of which they completed this year, and Zhaowan, which they completed 2 years ago. These are all, huge dams. Now, these huge dams on international rivers do affect river flows to neighboring countries. An international norm that needs to be developed and enforced is that countries have a right to utilize water resources without materially altering cross-border flows, right? But when you build dams of this size, you are intentionally, knowingly, materially altering cross-border flows. The question is, what can the downstream countries do? Now, some countries have water treaties. For example, India has only 2 downstream neighbors, Pakistan and Bangladesh. And it has water-sharing treaties with both. In fact, with Pakistan, the water-sharing treatment that India has is the world's most generous water-sharing treaty. In fact, it involves the greatest amount of cross-border flows through a sharing treaty. It allows a flow 90 times greater than what the United States agreed to in its water treaty with Mexico in 1944. And yet, between Pakistan and India, water has not ceased to be a bone of contention, right? Every time India builds a run-of-river dam, which I mentioned is non-consumptive, the Pakistanis object, and they've taken one such dam to the international arbitration, to the International Court of Arbitration. But at least when you have a water-sharing treaty, there's a mechanism in place to diffuse disputes. If you have a dispute with a neighbor, the treaty provides for arbitration, or provides for third-party mediation, or provides for something else, right? Or it provides for taking the matter to the International Court of Justice. But every water-sharing treaty normally has some dispute settlement mechanism in its place. So in the case of Pakistan and India, you can be sure that even though water is still a contentious issue, it will not escalate to open conflict, because there is a mechanism in place on how to resolve disputes. But when you have water appropriation by one country on a large scale, and that country refuses to even accept the concept of water sharing, like China does, it just doesn't believe in water sharing, then the question is, what can the downstream countries do? Well, the downstream countries are all of them, weaker than China. And therefore, because they're weaker than China, what can they do? Just complain. This is what they're doing.
The gentleman in the fourth row there. Yes.
Is it on? Yes. Thank you very much for the presentation. My name is Dr. Remy Piet. I'm assistant professor at Qatar University International Affairs, before with the United Nations Environmental Program. I wanted to use the opportunity of having a water expert here, which I'm absolutely not, to ask a question on Northern Africa specifically. Before that, maybe just to bring additional information to the first question, Qatar today is using 460 liters of water per capita and is number 3 in the world in terms of water consumption, just behind the US and Australia, and facing a water stress situation which is far worse and far more complicated than the US and Australia. On Northern Africa, there was a publication in April from British scholars, I think it was an environmental research paper, talking about huge resources of underground water. This was very surprising.
Where?
Sorry?
Where?
In Northern Africa.
Northern Africa?
Yeah, of groundwater resources. I wanted to know if that study had been confirmed since, and if maybe it was possible to find similar resources of water in Asia also.
Well, thank you for asking that question, because that allows me to pinpoint something which I had actually not mentioned. I'd mentioned about unconventional sources of supply, right? I talked about wastewater, talked about seawater, rainwater, but I forgot about one natural unconventional source of water, which is not just the aquifer water. It's the water deep down in what's called fossil aquifers. Now, what is fossil aquifer? Fossil means ancient, ancient. Ancient aquifers are aquifers, underground basins, where the water has accumulated over tens of thousands, maybe even millions of years, because they're so deep, drop by drop, every year, water has percolated down to that basin. Today, what's happening because of water scarcity? Countries are tapping fossil aquifer water. United States, for example, has one of the biggest fossil aquifers, which is spread across several states. And that's a very important source of supply in those states. In Northern Africa, Libya, take the case of Libya. This country's cities are all located along the northern coastline, right? 97% of Libyans live along the coast in those cities. And the water comes from deep south, from the Sahara, from fossil aquifers. There's only one fossil aquifer there, which they're tapping. 50 years or 100 years from now, will they have any water left in that aquifer? Probably not. Because that aquifer is also being tapped by some other countries, because it's an aquifer that actually straddles several countries, right? And I think this is the dilemma that we face, that we're running out of sources of supply. And if we're not able to come up with solutions in time, then a great ecological disaster is going to unfold, because when you completely drain out fossil aquifer, that itself will have major ecological consequences. It'll cause land sink. We are seeing that already, where groundwater is overexploited, the land sinks in. And soil itself is being degraded because of wrong agricultural practices, because overutilization of chemical fertilizers. So we face multiple challenges on the resource front. And water, of course, as I mentioned, is the most critical of all natural resources. And how we address that will determine whether we're going to avert water wars.
This will have to be the final question. The gentleman in the back row there, please.
Thank you, Doctor. I wanted to compare the impacts of the Himalayan region to namely that of North Africa, because in most climate change models, for some reason or another, Africa appears to be the worst off. And one of the reasons they say is because of the Nile Basin and the possible water stress that could occur in the Nile Basin. So I wanted to ask, do you believe that the impacts in North Africa because of the Nile Basin will outweigh the impacts in the Himalayan region, and if so, why?
Well, I don't think so, because the Nile Basin doesn't have the glacial fields, the snow fields. Here, the snow fields are so large, the ice is enormous, the impact of solar radiation is more visible, and because of the high elevation of this region, this will be the first to bear the brunt of climate change. For those reasons, Northern Africa, the Nile basins cannot compare with the Great Himalayan region. But you mentioned the Nile Basin, which is a very interesting case, because here we have a completely different case. Here we have the lowest riparian. The Nile flows through 10 countries. But the country located downstream furthest, Egypt, consumes more than 80% of the waters of the Nile. And when upstream countries like Ethiopia or Sudan want to utilize the Nile waters for economic and other purposes, Egypt is very quick to caution them, if not warn them. Now here you have a case where the country located furthest downstream is militarily the strongest country. And therefore, upstream countries have to think twice before doing anything that would annoy the country located furthest downstream. Now here is the power logic reversed on its head, where the downstream country demands and actually ensures the dominant supply. You have the same case in Central Asia, Uzbekistan. Uzbekistan, the suppliers of water in Central Asia are Kyrgyzstan and Tajikistan. These are two small countries. They are energy poor, they have no hydrocarbons, and the main users of their waters are the big hydrocarbon-rich countries, Uzbekistan and Kazakhstan. And Uzbekistan in particular has publicly threatened military action against Tajikistan if it were to proceed with its Soviet-era plans to build large dams on the rivers that flow downstream. So again, here is another case where the downstream power prevails over upstream capacity to utilize those resources as a strategic asset.
Dr. Chellaney, this has been a very long day for you, and it will get even longer because you're returning to New Delhi in the wee hours of the morning. I want to thank you for treating us to a real feast of information and insight into the huge and hugely important water issues of Asia. It's been an absolutely wonderfully interesting evening here. Thank you also for your extremely good questions, as always. We hope to see you in 2 weeks for the 5th and last of our series on climate change. Once again, thank you so much for being with us this evening.